Hello, good evening, dear students. So let us start discussion our classes in continuation of whatever we discussed in the previous class. So today we are going to start with measures of dispersions. So far we have learned about that measure of central tendency. The measures of central tendency are not always adequate to describe data, and hence there is a concept of measures of dispersion. I would like to give you a representative example, so that by looking into that example, you will understand that why that measures of central tendency are not adequate to describe the data. Let's see, by means of this example. Before I proceed further, could you please confirm that you are able to hear my voice very clearly, dear students? Just for
Yes, sir.
Okay, great. Thank you very much. As you see, the measures of the central tendency, as it is written here and I just said, are not always adequate to describe data. Two data sets can have the same mean or median or mode, but they can be entirely different. Let us understand by means of that following, illustration. As you see, dear students, that there are two persons, person A and person B, and the data as you see in front of the screen are the amount saved by these two persons in the last 4 months. The person A saved rupees 499, rupees 500, rupees 500 and rupees 501 in the first month, second month, third month and fourth month respectively. Whereas person B saved rupee 1, rupees 500, rupees 500 and rupees 999 in the first month, second month, third month and fourth month respectively. Now, if you just focus on the measures of the central tendency, you will find very interesting thing that mean, median and mode of these two data sets for person A and person B are same. You can compute, as you know how to compute the mean, median, mode. So now, what we get is that if you compute the values of the mean, median and mode for these two persons are exactly same, and it is equal to 500. So then what? Then how we can conclude? How we can characterize this data? We are not able to characterize this data. Okay. So here we see for this particular example that measures of central tendency is not able to interpret the data. So as it is not able to interpret the data, we should have an idea how the data are scattered. Okay. Or how much they are bunched around a measure of central tendency. Very important statement. I repeat once more, dear students. So in order to make better interpretation from the data, we should also have an idea how the data are scattered or how much they are bunched around a measure of central tendency. And this leads to the new topic called the measures of dispersion. We'll understand this thing. The measures of scatter of a data is measured on the basis of observations and about the types of the nature of the in the measures of the central tendency like mean or median used here. We'll look into all these things. So the dispersion or scatter in a data is measured on the basis of the observation about the type of the measure of central tendency. Let me first write it down and then let me explain in details about why it is, how finding the measure of dispersion, the measures of central tendency are important. Let me first point the note here and then after that I will explain. So if you look into this note, dear students, is that the dispersion or scatter in a data is measured on the basis of the observations and about the types of the measures of the central tendency. What it mean by that? So the dispersion or scattering of the data, if you see the money saved by these two persons, person A and person B, how they saved their money, how the data are scattered, and those scattering of the data should be measured, okay, with respect to the measure of the central tendency. That means how they are scattered with respect to the mean of these numbers, or how they are scattered with respect to the median of their numbers. Okay, so the way we are going to compute the dispersion or scatter in a data is measured on the basis of the observations of the mean of this data and median of this data. We will see in details of this thing. And what are the measures? The measures are here are the measures. The first one is called the range, as you see, dear students. That first one is called the range. Second one is called the quartile deviation. Third one is called the mean deviation. And fourth one is called the standard deviation. And variance is related to that. I'm come to that. So here in this discussion, we are going to discuss range, mean deviation, standard deviation, and eventually the variance. We are not going to discuss about quartile deviation. We refrain our discussion to with range, mean deviation, and standard deviation. So let's understand what is range. Range is a measure of dispersion of data. It is quite simple, and you will appreciate once you understand this thing. So what is range? Let me take you to the next page and explain about the range. So the simplest measure of dispersion is the range. The range is the difference between the minimum and maximum value in a group of observations. So we get the formula to calculate the range is that a range is x max minus x mean. That is the way we compute the range. So let me first place the note in front of you, and after that I will explain. So as you see, dear students, in front of the screen, the range is the difference between the minimum and maximum values in a group of observations. Okay, so we get the following formula to calculate range. Range is equal to x max minus x mean. What is x max? In the given data set, what is the maximum value that is known as x max? And in the given data set, what is the minimum value is known as the x mean. So for example, if you look into the data set, that is which describes the yield of eucalyptus from different plot, and it is the yield described in ton per plot, as you see it here. So these are the 10, 12, 6, 19, 20, 25, 22, 29, 5, and 11. So what is the range? Range is the x max minus x mean. So what is x max? X max is 29. That is the maximum number of all these values, and x mean is 5, which is the minimum number among all these values. So we get the range as 29 minus 25, that is 24 ton per plot. So this is the fundamental idea about the range. I hope it is very clear, dear students, that what is range. Now, as we understood about range, there is another terminology that is called the range coefficient. So how we define the range coefficient? The range coefficient we define is something like this. That is, let me first bring that note here, dear students, and after that I will explain. That we define the range coefficient as x max minus x mean divided by x max plus x mean. So with respect to the above example, what we find that range coefficient as 29 minus 25 divided by 29 plus 25, that is 24 by 34, that is 0.705. That is the range coefficient. So now let's quickly understand the merits and demerits of range. So let me first place the note in front of you, dear students, and after that I will explain that what are the merits and demerits of range. So dear students, as you see in front of the screen, the merits of range are like it is simple. easy to understand, and quickly calculated. And what are the demerits? Its value fluctuates with size of observations. It is unstable in repeated sampling. It is very rough measures of dispersion and not suitable for precise and accurate studies. Now, on all these demerits, dear students, you can get a realization if you make some experiment with a relatively large data set. The example what I gave, it is having, 1, 2, 3, 4, 5, 6, 7, 8, 10 data set, 10 data points, right? So if you take little larger and then you started finding the range, then you'll find these are the demerits. But merits, you don't need to experiment. It is easily understandable. It is simple, easy to understand, and quickly calculated. All the three are true. But for demerits, you need to make some experiment to get a realization what are the demerits of the range, as long as the method of dispersion is concerned. Now, dear students, the next point what we are going to discuss is that is called the mean deviation, and this is extremely important. This is extremely important, and you will get a lot of questions you will get in your exam on mean deviation. And first, let's understand what is mean deviation. And dear students, if you have your understanding clear, then it will be very, very simple. They are just methodologies. You need to follow those methodologies to calculate all these different things that of a method of dispersons in different attributes you can find very easily. How you can, that will know after some time. But let us understand why that term mean deviation came into the picture here. Okay. The deviation, what is mean by deviation, dear students? Deviation means that how it is different from a value, fixed value. Then it's called deviation. No? For example, if the highest mark in an examination is suppose highest mark in an examination is 90, then if we calculate the marks of the other students, then how we are going to calculate it? The way we are going to calculate it is that how much it is different from your marks and the highest mark, for example. So the point what I'm going to mention, dear students, is that so then the difference is actually, we can say that how much it is deviated. Okay, how much it is deviated, that is the way we describe that, the word deviation. If you look into the English dictionary, and you will get to know that what is the meaning of deviation. Deviation means that how much it is actually from the standard one, how much it is actually fluctuating. That is what is called the deviation. Okay, dear students, so I hope you got an idea that what is meant by the deviation.
Yes, sir.
Okay, great. Thanks. Now, so let me first give you the definition, and then we will discuss about more on it, and then we will see that why the fundamental definition has an issue, and we will change it accordingly. So as I was telling, dear students, that the deviation of an observation X, okay, from a fixed value A, that fixed value will actually play a very meaningful role here. And in that fixed value, we will see the measures of the central tendencies like mean and median, basically, not mode, generally mean and median. The difference X minus A, the difference is X minus A. The deviation of an observation X from a fixed value A is nothing but X minus A. So in order to find the dispersion of values of X from a central value A, that central value A, dear students, is very meaningful. Central value A means, I will say after some time, is that I will explain after some time, is that that central value is actually here is denoted by the mean or median. That central value is denoted by the mean or median. We find the observation about it. Sorry, we find the deviation about it. So an absolute measure of dispersion is the mean of these deviations. That means x is variable. So suppose x is having values x1, x2, x3 up to xn. That means what I'm saying is that x may be having values x1, x2, x3, up to xn. Now, dear students, as we are calculating the deviation from a fixed value a, let me use a different color to describe the value a. A is a fixed value, or that is what is known as the central value. Then what we are going to calculate, dear students? We are going to calculate that x1 minus a, then x2 minus a, then x3 minus a. These are the difference and known as the deviation of all these values x1, x2, x3, up to xn from the fixed value a. So x1 minus a is nothing but deviation of x1 from the fixed value a. x2 minus a is nothing but the deviation of x2 from the fixed value a. x3 minus a is nothing but the deviation of the value x3 from the fixed value a. So that is the way we calculate. Then the absolute measure of dispersion is the mean of these observations. So we need to find the mean of these observations. So how we can calculate the mean of these observations, dear students? That is very simple. You need to add all these things, x1 minus a plus x2 minus a plus x3 minus a plus xn minus a divided by the number of observations in this discussion it is in. So that is the mean of deviations. But there is a catch. What is the catch, you know? If we follow this methodology, or if we follow this fundamental definition of the mean of deviations, we will find that value of the mean of deviations can be 0. How? Let's see. Let's see by means of this example. And if we get 0, then you really cannot conclude anything out of it, right? So let us take, and I always take a very simple example so that it is very easy to understand. And after that, you can apply that understanding with relatively large problems. So it may possible that, as I was telling, that sum of all these deviations is 0. That means what? x1 minus a plus x2 minus a plus x3 minus a plus up to plus xn minus a could be equal to 0. So hence the measure of, so what we can say is that hence the mean of these deviations shall be 0. Let us understand by means of this example. Suppose let us consider the amount saved by a person in the last 4 months is something like this. In the first month, the amount saved is rupees 499. In the second month, it is rupees 500. In the third month, it is rupees 500. And in the fourth month, it is rupees 501. Then, according to our understanding, that if we find that how it is deviation about the mean, what is the fixed value then here, dear students? What is the fixed value? A here, the fixed value, the central value is the mean of all these 4 numbers, that is 499, 500, 500 and 501. What is the mean of all these 4 numbers? If you add 499 plus 500 plus 500 plus 501 divided by 4, that means if we do something like this, 499 plus 500 plus 500 plus 501 divided by 4, what you are going to get? You are going to get the value as 500. Now, dear students, that if we take that central value as 500, and if we subtract that 500 from each of these numbers, that is 499, 500, 500 and 501, these are x1, x2, x3, x4 in context to the information what I shared with you, that x1, x2, x3 up to xn are the in values of these variables. So then what we are going to get, dear students? So we are going to get the value is something like this. Okay. Let me give the entire note here relevant to this particular discussion, and then let's from there let us discuss. So now, if you see, dear students, that all this difference from the value a, which is 500, what are the differences we are getting? For 499, this is the difference, 499 minus 500. For 500, what is the difference we are getting? 500 minus 500. For this 500, what is the difference we are getting? 500 minus 500. For this 501, what is the difference we are getting? 501 minus 500. Now, if we make this difference, then 499 minus 500 is minus 1. 500 minus 500 is 0. Here also 500 minus 500 is 0. And 501 minus 500 is equal to 1. Now, according to our fundamental definition of mean of deviations is what? Sum of all these numbers, minus 1 plus 0 plus 0 plus 1, which is equal to 0. So that means sum of deviations is equal to 0 and number of observations is equal to 4. So mean of deviations become what? 0 by 4, that is equal to 0. But what you can conclude? If I tell you, if you give me a data set and I tell, mean of deviations is 0, then what you are going to conclude? You are not going to conclude anything, dear students. Hence, we see that finding the mean of deviations about mean is not of any use in context to this particular example. Okay? As far as the measures of dispersion is concerned, then what? Then the best way of choosing is that whether we can find the absolute value of the deviation. That means by eradicating the negative value. That means instead of minus 1, can you take plus 1? How to do this thing? But there is a terminology for that. So what is that? In finding a suitable measures of dispersion, in finding a suitable measure of dispersion, we require the distance. I'm coining a new term called distance of each value from a central value of tendency for a fixed number A. Earlier what I said deviation. Now I'm using the word called distance. Okay. Now what is distance? Is always a non-negative value, the absolute value of the difference of two numbers. The distance value, the absolute value of difference of two numbers gives the distance between the numbers. Correct or not, dear students? So what I'm saying is that something like this. Suppose I have a fixed number A. Okay. And now what are the values I'm having? X1, X2, X3, and in that way I go, let me make it a little proper, X3, then in that way I go up to Xn. Then what is the difference, dear students? The difference is that X1 minus A, but X1 minus A is deviation. From deviation we are converting into the distance, that is mod value of X1 minus A. That is called the distance. Similarly, for X2, we are computing X2 minus A, its absolute value. That means non-negative value. And dear students, you know from inequality and complex number that how we describe the non-negative value. That is a mod. That is a symbolic representation of a non-negative value. Correct, no, dear students? So what I say here is that X3 minus A. And in that way, it is continuing till Xn minus A. So these are the non-negative values. Now, if we add all these values and divide it by the number of observations, then we cannot get 0. Unless a very specific case that all the values are equal. That is different. Then we cannot get the value 0. So that is why we are, that this is the way to find the mean deviation about the number A. So, so let me first place the note in front of you, dear students, and then let me explain further whatever I said to get more realization of by means of this note. So I read this statement, dear students, as you see in front of the screen, is that in finding a suitable measure of dispersion, we require the distance of each value from a central tendency or a fixed number A. So we require, I write it, I underlining that line, underlying this statement, we require the distance of each value from a central tendency or a fixed number A. We know that the absolute value of the difference of two numbers gives the distance between the numbers when represented on a number line. In a number line, real number line, if you take two, suppose if I use a different color and explain, suppose in a real number line. So this is a real number line. And in that real number line, we take 2 points. Point here 1 and another point here. Suppose I take the point here is P1 and here it is P2. So what is the distance between P1 and P2? It is the distance between P1 and P2 is the absolute value of P1 minus P2. That means they are non-negative difference. If P1 minus P2 is negative, we will take the positive value, and if P1 minus P2 is positive, we will take the positive value. Correct, dear students? So that is what is the term is distance is there. Okay. Hence, to find the measure of dispersion from a fixed number A, we may take the mean of the absolute values of the deviations from the central value. This mean is called the mean deviation. So how we can find the mean deviation? So mean deviation about a central value A. You receive, dear students, that here I am saying central value A. That central value A can be a mean, can be a median. So this central value can be either mean or it can be median. So dear students, you find that while we are finding the different methods of measures of dispersion, during that the central tendency methods are also helping us, like mean and median. How? You will know after some time. So the mean deviation about a central value A is denoted by MDA and is defined as the mean of the absolute values of the deviations of the observations from A. So we are changing the definition of MDA, that is a denotation denoted by MDA, that is the mean deviation about a central value A is denoted by MDA and is defined as sum of absolute values of observations from A divided by number of observations. So now, dear students, let us look into this with respect to the same information. Then how you will get it? You will find that all these values, what we are getting, -1, 0, 0, 1, we will get these values as positive values, that 1, 0, 0, 1. What I wanted to mean is that if I take the previous note and what we will get is that something like this. Just a minute. So this is the previous example. I am taking it here, but I will modify a little bit here, because as we know, the absolute, the sum of the absolute values of deviations. So what is the absolute value? So these are the data sets, and we found the mean is 500. So we are making that 499 minus 500. So you see it is -1, but the moment we take the absolute value, then it become -1 become +1. The rest of all the values will be as if they are positive. All these values, 500 minus 500, 500 minus 500, 501 minus 500, these are all non-negative values. So we do not consider the mod value. So now if we add all these values, 1 plus 0 plus 0 plus 1, so what we are going to get? 4. Now if we find that mean deviation about A, where A is equal to 500, that value will be what? That value will be 4 divided by number of observation is 4. Sorry, this I made a small mistake here. So sorry, this is 2. So this is equal to 2, and what we are getting is that here the mean deviation about that point is that here it is 2 by 4, and that is actually 0.5. Got it, dear students? That how we are. What is the motivation behind, or what is the justification behind that to consider the absolute values? Correct, dear students? So I hope you have a very clear understanding. Now, what we are going to do, dear students, is that how we are going to find that mean, means that what is the central value. I gave an indication that central value we are going to take either by means of that mean or median. Mean deviation. So this is a very important information I'm going to share with you. That mean deviation may be obtained from the measure of central tendency. However, mean deviation from mean and median are commonly used in statistical studies. So what I'm saying, dear students, let me repeat. Mean deviation may be obtained from any measures of central tendency. However, mean deviation from mean and median, that is the central value. That is mean deviation from mean and median are commonly used in statistical studies. So let us now learn how to calculate mean deviation about mean and mean deviation about median for various types of data. Why various types of data? We have seen our earlier classes that the data are mainly categorized into ungrouped data and group data. Again, the ungrouped group data are classified into discrete frequency distribution and continuous frequency distribution. So what I'm going to do, dear students, I'm going to give you this diagram, and then you will have a very clear idea about that, why I'm talking about that, all these different type of data and how we can form that measure of central tendency about mean and about median for these types of data. So here I'm going to use different colors as well. So what is our purpose? Our purpose is to find mean deviation, right? That is our purpose. Our purpose is to find mean deviation. Now, mean deviation for ungrouped data. If it is ungrouped data, let me use a different color. If it is an ungrouped data, then ungrouped data mean deviation about mean, and ungrouped data's mean deviation about median, which I shown in the green color. That we need to do. That we will do. That mean deviation of ungrouped data about mean and mean deviations of ungrouped data about median. So two things. We'll do all these things in the today's, if it is time permits, or in the subsequent classes. Now, if you remember that ungrouped data, the group data are classified into either discrete frequency distribution or in continuous frequency distribution. Now, in discrete frequency distribution, it means data represented in discrete frequency distribution manner. So for these group data, we can find the mean deviation with respect to mean, about mean, not with respect to mean, about mean. So I repeat once more, the discrete frequency distribution of group data, finding the mean deviation about mean, and discrete frequency distribution of the group data, mean deviation of the group data described in discrete frequency distribution about median, whatever I have described in the blue color. Then what remaining? Remaining is that, the continuous frequency distribution, as you see. So then continuous frequency, so mean deviation of the continuous frequency distribution data of the group data about the mean, correct? And finding the mean deviation of the group data of continuous frequency distribution about the median. So then what we found? We found, so there are different ways of finding the different set of way of finding it, that ungrouped data mean deviation, group data mean deviation. Mean deviation about what? Mean deviation about mean deviation about median. Then group data is classified into discrete frequency distribution and continuous frequency distribution. Discrete frequency distribution, then mean deviation about mean, then discrete frequency distribution, mean deviation about median. Then continuous frequency distribution, mean deviation about mean, then continuous frequency distribution, mean deviation about median. So, so total 6 categories we have observed now. What are the 6 categories? First category is that ungrouped data, mean deviation about mean. Okay, let me use the uniform color so that it is all understood. Or maybe I can use a completely different color. Maybe we can use this color. So ungrouped data, mean deviation about mean. Ungrouped data, mean deviation about median, 2. Then group data. So discrete frequency distribution, group data, mean deviation about mean. Discrete frequency distribution, group data, mean deviation about median. Then continuous frequency distribution, group data, mean deviation about mean. Then continuous frequency distribution, group data, mean deviation about median. So these are the different ways we are going to find the measure of central tendency. I hope it is clear, dear students. Okay. Now, what I want to do is that mean deviation for ungrouped data. What I'm going to do now is that mean deviation of the ungrouped data. So how to find the mean deviation of the ungrouped data? So by informing this, we will conclude the class for today, and then in the next class we will discuss in more details about that, how to find that about mean and about median. So let me first bring the entire note in front of you. After that we will discuss. Okay. So if you look into this, dear students, the mean deviation for ungrouped data. Okay. Let us there are n observations of ungrouped data like x1, x2, x3 up to xn. x1, x2, x3 up to xn. Now, mean deviation of these ungrouped data can be obtained by means of the following manner. Mean deviation of ungrouped data about mean, as I was telling, that mean and median, these are the central tendencies, methods of central tendencies, and mean deviation of ungrouped data about median. So how to find it out? Pretty simple. For n observations x1, x2, x3 up to xn, the mean deviation about a central tendency x is denoted by MDA. And how it is defined? It is the summation of the absolute values of x1 minus xi minus a, where I is varying from 1 to n is the number of observations, divided by n, that is the number of observations. So how to find by means of this in a step-by-step manner? I always prefer to give all these things in step-by-step manner so that it is very clearly understood. So what will be given to you? A data set will be given to you. That means a set of values will be given to you. For example, in the today's class, we have observed that the amount of money saved by the persons. In the previous class, we have observed the scored by 2 batsmen. These are the data will be given. So after receiving the data, dear students, the step 1 should be calculate the measure of central tendency about which we are to find the mean deviation. So let this be A. I will explain you, dear students, after that this A should be either mean, okay, or it will be median. I explain you once more, dear students. Step 1 is that calculate the measure of central tendency about which we are able to find the mean deviation. We are finding mean deviation, but mean deviation about that what value? That is a fixed value A. So it could be either mean or median of the given data set. So then step 2 is that you find the value of xi minus a for I equal to 1, 2, 3 up to n. Once you find that one, then find the absolute value, that is non-negative value, that is mod of xi minus a. Once you find that one in step 3, then in step 4, we need to find that the value of mean deviation, okay, about A is denoted by MDA, and it is calculated as sum of all these values as we obtained in the step 3 divided by n, the number of observations. Okay, dear students, so have you as you understood this thing, so let us take on example. Okay, and so here as you see in this whatever I have described so far, we only describe about the central value A. Now as I showed you, the central value A could be either mean or it could be median. So now let's first take the mean. So what we are going to discuss now? We are going to discuss now that mean deviation for ungrouped data about mean. I repeat, the mean deviation for ungrouped data about mean, and that is the point of discussion now. So how to find it out? Let's look into it. It's pretty simple based on the concept whatever we just learned. Only thing is that, dear students, you need to make a little bit of practice so that it will be absolutely clear. So the mean, let me first, place that entire note as long as this definition is concerned. After that, we will see one example. So dear students, if you see the mean deviation of ungrouped data about mean, I repeat, dear students, the mean deviation of ungrouped data about mean is what? X bar is denoted by MD X bar. In previously, we defined that MDA, where A is the central value. Now that central value we are considering as mean. Then the mean deviation of ungrouped data about mean is X bar is denoted by MD X bar and is obtained by means of the following two steps. Step 1, for the given data set, find the mean, that is X bar, which is very simple. How it is simple? You need to add all these values divided by the number of observations. You get X bar. So now replace A by X bar in the previous definition. That means previous definition was what? This was the previous definition. Now let me use a different color. This was the previous definition, right? So in this definition, what was there? MDA is equal to, numerator is summation I equal to 1 to n mod of xi minus a divided by n. And here what we are defining, we are making this a replacement, that A by X bar, and we get, this is the definition, and this is the one to finding the mean deviation about the mean. I repeat, dear students, mean deviation of ungrouped data about the mean. Now I know you understood, but this understanding will be very rock solid if we go with an example. So to find that example, so let's first consider the following data set, dear students. So here is the data set, as you see, that let us understand by means of that example. Let us find the mean deviation about the mean for the following ungrouped data. And you are already aware of what is ungrouped data. If it is not, you can look into my previous video lecture. Okay, let us first find the mean deviation about the mean for the following ungrouped data. So these are the data: 38, 70, 48, 40, 42, 55, 63, 46, 54, 44. So now first step is what? First step is that, dear students, we need to find the mean of all these values. Now if we compute the mean of all these values, then what we are going to get? We are going to get pretty simple: 38 plus 70 plus ... up to 54 plus 44 divided by the number of observations, which is 10 in this case. That means what? What you are going to get? You are going to get something like this. And this value is equal to 50. Correct, dear students? Did you get it? This value is equal to 50. Okay. Now, okay, thank you. This is X bar. Now, what we are going to do is that now we are going to find that mod value of this xi minus X bar. And for that, I generally recommend students to use a table. If you use table, then there is a very less chance of making any mistakes. So how? Let me show it to you. So now we form the following table towards computing the mean deviation about mean. Okay. So how to compute that one? So let me first show you, dear students. This table is important. So what are the different values here? 38, 70, 48, 40, 42, 55, 63, 46, 54, and 44. What is the mean of all this data? That is 50. That is uniform, 50. Then what is the difference xi minus X bar? That is 38 minus 50, that is minus 12. Then 70 minus 50 is 20. Then 48 minus 50 is minus 2. Then 40 minus 50 is minus 10. Then 42 minus 50 is minus 8. Then 55 minus 50 is 5. Then 63 minus 50 is 13. Then 46 minus 50 is minus 4. Then 54 minus 50 is 4. Then 44 minus 50 is minus 6. So we get these values xi minus X bar. But what is our objective? Our objective to find the non-negative value. That's why we define mod of xi minus X bar. That means whatever we get in the previous column, we will take the positive value only. If it is minus 12, so we take 12. 20, 20, minus 2, 2, minus 10, 10, minus 8, 8, 5, 5, 13, 13, minus 4, 4, 4, 4, minus 6, 6. Add all these values. Whatever we are getting, 84. Then what we are going to get, dear students? So then we see that summation is 84. So our mean deviation about mean should be 84 by 10. That is the number of observation, which is 8.4. And that is the mean deviation about mean for the given data set of ungrouped data in this case. So I hope, dear students, you understood it very clearly. If something is not clear, never hesitate to let me know. In the next class, dear students, we will see the mean deviation for ungrouped data about median. The way we see it mean, we need to find out about median. For that, what you need to do? Let me give you a very preliminary idea. You need to find the median. Instead of x bar, you need to replace by median. Okay, in fact, you can do it also. Once our class is done, you can do it by your own. And you can verify that in the next class when I will going to discuss, and you can verify whether it is working properly or not. So with this note, dear students, I would like to conclude the class unless you have any specific question of whatever the topics we have learned today. Okay, if you do not have any query, then we can conclude the class now. Thank you very much.
Thank you, sir.
Thank you.